I promised not to be too political this evening, but this is what really kicked off my decarbonisation report that I'm working on at the moment, because when I read this, which was given at the party political conference in 2021, and then, well, it was 2 years in a row it was given, I thought this... yes, I saw this and I just thought this isn't right, and I spoke to some academic friends and they said no, and actually Taj had written something in Creds about schoolboy errors. He basically was saying that we have not really got far to go to get to 100% renewable energy for all our domestic uses, for our houses and our cars and washing machines and whatever. So the reality, this is looking at the primary energy of the UK using 2019 just before the pandemic. The reality here is that there is about our wind, offshore and onshore wind and solar here is around about 4%, just over 4% of the total UK energy consumption. And that's very, very different to what most people think. You hear, oh, today the wind blew quite a lot and provided quite a lot of our electricity. Well, apart from the electricity being that, and this is just that tiny little bit of it, this is the gas and this is the petroleum. And this is from Government BEI's data, which is Energy Consumption UK, which is published every year. And where does that get used? So transport is a big user, and space and water heating is a big user. And road transport is that top bit, and aviation. Now this, you need to realise that is just the fuel that's put in the aircraft in the UK. So if someone does a return trip, and most trips from the UK are, or to the UK are return, it's double that. So aviation is a big factor, and it make that graph considerably taller than it is. And then another thing to consider is that electricity production, most electricity, apart from the 4% that comes from renewable sources, involves a lot of waste. So all this red here is the waste in electricity, and that means that there's about 2.2 times as much energy goes into the electricity system as comes out in the UK. So gas, and that's the waste for gas. This is bioenergy, which is the worst of all. Look how much waste. It's something like, you get about 25% of the energy you put in comes out as electricity. It's really, I think, just a way of getting rid of rubbish. And then nuclear here has got a big chunk of waste as well. And there's no waste. Most of that waste comes from heat from the turbines. So if we're going to deal with decarbonising the environment, or our energy system, then first thing we can do is get rid of all that waste by just turning it all into renewable energy. But that does mean we need to increase our total onshore and offshore energy or electricity production by 3.5 times just for that task. That's without decarbonising petroleum and gas, i.e. cars and heating. So it's a big challenge. And then the next thing is to looking at transport. Fortunately, electric cars are much more efficient than, or electric motor is much more efficient way of moving you forward than an internal combustion engine, which again wastes an awful lot of energy through heat and other inefficiencies. And so you win by you basically reduce the amount considerably by electrifying, and then you need to move that electrification over onto this stack to add on to the renewable energy. And then if we then do the same with buildings, Now, this is just the second to last slide, that if we do retrofit and heat pumps, there's a win-win, and we get a really good reduction, because a deep energy retrofit can save 80% of the energy consumption and give you a fairly even demand for energy throughout the year. And that means that the fairly even distribution of renewable energy matches that fairly even demand. And heat pumps are great because they, on average every year, they've got a COP of 3, which means that they're taking a lot of the heat out of the air. You're not just burning this valuable resource, gas or oil or something. You're actually just taking a lot of heat out of the air and multiplying the benefit. Now, what happens if we don't retrofit buildings? The problem here is peak demand, and it's we've gone through. Actually, behind this there's a whole paper and a whole load of spreadsheets are going to be published, and peer reviewed and published. But the gas grid publishes data of gas use every day, and actually at several intervals a day, between 4 and 6 intervals a day. So we can see, and we've taken away through other ECAC data some other uses in order to get to gas heating, and then we've looked at how the gas demand for heating in the UK across the UK's buildings differs between the average over the year and the peak. Because what we need to remember is that it's not just a matter of taking the amount of energy that we consume at the moment, which is all like stored gas. It gets stored and then is binged in a great spree in the winter. With electricity, with renewable electricity, you can't do that. So the whole system needs to be capable of dealing with the worst case. And that just means more capacity. So you basically end up going off the scale 20 times because again, in a passive house or deep energy retrofit, you don't need to have call on your heat when it's really cold, as Alex will tell you in his own house. The heat goes off, you can switch it off for a week in a cold spell and you'll barely notice it. So that means you can really demand manage. But if everyone is in unretrofitted buildings and all wanting the heat now, then you're going to have this first peak factor, and then you're going to be getting your heat when most people use air source heat pumps when it's most inefficient, because the air is so cold you can't get that much heat. So it's almost neat electricity being used at that point. So energy efficiency that's why I'm doing what I'm doing, and I know that's why Alex is doing what he's doing. It's the first thing that we have to do. We can't just go and bolt on renewables and expect to have a hope of avoiding a kind of catastrophe, I'm afraid.